This is activity 1, which one doesn't belong, and this is looking at equations from lesson 7, all, some, or no solutions. And in this activity, you're supposed to identify which of these equations is different, makes it different from the remaining 3 for each equation. So why does this one not belong to the other 3? Why does this one not belong? And so on, all the way down. And so I'm going to use this activity to review some basic properties of arithmetic, namely the commutative property of addition. So this one shows the commutative property of addition, the commutative property of multiplication. So this one shows the commutative property of multiplication. I'm also going to review what the difference means. So this was Unit 5 from 7th grade. So how do you calculate the difference between two numbers? So the difference of two numbers, you have a distance between the two numbers and a direction between those two numbers. And finally, that subtraction is not commutative. You don't get the same answer if you change the order. You do get the same absolute value. So 5 is 2 units away from 7. 7 is 2 units away from 5. But in this case, the answer is a -2. In this case, the answer is a +2. So we'll go over these in some detail. So for the first one, 5 plus 7 equals 7 plus 5. This does show the commutative property of addition. So if you walk up to a counter and you place 5 apples on the counter first, and then 7 apples on the counter second, you have placed a total of 12 apples on that counter. Now it's a different problem. It looks different if you go up and place 7 apples on the counter first and then 5 apples. You still have placed 12 apples on the counter, but it's a different problem. So the commutative property of addition says the order in which you operate doesn't change the answer. You still get the same answer, although the problem can be different. It looks different, but the answer is the same. So different expressions. This is a different expression than this expression, but the value of each expression is equal. So that means you can move these add-ins around, and it doesn't change the answer, and that's useful when solving equations. The order of the terms does not change, but the value does not change the value of the expression. So whatever order you have them, it doesn't change this value, the value of the expression. All right, for the second problem, this shows that multiplication is commutative. So the order does not change the answer, although it looks very different. And it's even, you can even see the difference, a greater difference, using multiplication than addition. So in this case, if you think of multiplication as groups of things, so I have 5 groups of 7 things in each group, or I have 7 groups of 5 things in each group. So this one on the left, 5 groups of 7 apples per group. I have a total of 35 apples. But that looks very different from having 7 groups of 5 apples per group. I still have a total of 35 apples. So if I take all the apples out of the bag, and that's what you do mathematically when you do the multiplication. In effect, you're taking all of the apples out of the bag, and you're calculating the total number of apples as 35 apples. But it looks different. This is 5 groups. This is 7 groups. So different order of factors. So it's as if you remove the apples from the groups. So if I take all these apples out and then regroup them into 7 groups of 5 apples, I'm going to have a different number of groups. Although these expressions are different, they are equivalent. So again, you can use this idea to solve equations. Now this gets pretty intense. This was one of the more difficult units in 7th grade. This is Unit 5 in 7th grade, showing the difference of two numbers, how you view that, how you think about that. And if you use a number line, first of all, I'm going to remind you that the difference Well, let's go through this first. The difference between 7 and 5 is equal to a positive 2. This is 7th grade, unit 5. So when you look at the difference of two numbers, you can look at them using the inverse operation of addition. So this is how you learned subtraction in 1st or 2nd grade. You learned fact families. So addition and subtraction fact families. So for example, 5 plus 2 equals 7, 2 plus 5 equals 7, 7 minus 2 equals 5, and 7 minus 5 equals 2. So you memorized that. And so if you write, this is the corresponding addition problem with this subtraction problem. And if you rewrite this as 5 plus 2, 5 plus 2 equals the 7 here, what you're doing basically is saying, I'm going to take the 5, I'm going to add 5, and plus some number. So 5 plus some number down here. I'm skipping around a little bit here. So 5 plus some unknown number is equal to 7. So 5 is the first addend, plus some unknown number right here is equal to the sum of 7. So when you say, what's the difference between 7 and 5, that 7 is the sum of this addition problem. 5 plus 2 equals 7. So what we do is we place a dot where that 7 is, and then answer the question of what's the second addend to get to that 7. So this 5 is the first addend. So 5 plus some unknown number is equal to 7. So 5 is the first addend. The second addend is unknown at this time, but you have to get to the sum of 7. So how do you get there? You add 2. So this is the sum. This is the first addend. So how do you go from this first addend to 7? You have to add 2. So that puts the 7 out here. All right, so 5 plus 2 equals 7. This is the first addend. This is the second addend. And this is the sum. So when you say, what's the difference between 7 and 5? The 7 is the sum. The 5 is the first addend. And you're calculating what the second addend is. And you find that as a positive 2. So it's the difference of the absolute values. So 7 minus 5 is 2 units. That's the distance between 7 and 5. And the direction is positive 2. So you move a positive 2 units from 5 to 7. So the second addend tells you it's a positive direction. Now this is hard, and there's a reason that the authors want students to understand the difference of two numbers on a number line, and we'll continue to review this as we go through lessons. Most teachers would just teach this as, in this case, 7 minus 5 is 2. But when you compare that to 5 minus 7, we're going to do that in a few moments. You're going to get an answer of negative 2. So we'll do that in a moment. This is tough. All right, so this problem shows you that subtraction is not commutative. So 5 minus 7 is a different answer than 7 minus 5. This is going to be a positive 2. We just did this one. This is going to end up being a negative 2. And the way that teachers teach this one oftentimes is 5 minus 7. Think of it as 5 plus a negative 7. So 7 minus 5 is 2. It's a negative 2 because there's more negatives than positives. So either way you look at it, working with positive and negative integers is confusing if you don't practice it a lot. It takes a lot of practice and a lot of careful thinking to get used to it. On a number line, this is the sum now. So the difference between 5 and 7, the first number you say is the sum. That's where you're going to get to. And you're going to move from 7 to 5. So you're going to move a negative 2 units. This one we just did, the difference between 7 and 5. So this first number that you say is the sum. And we're going to move from this 5 to this 7. So we're going to move a positive 2 units in this direction. On a number line, this is the sum, 5. So the first number you look at is the sum. That's where you want to get to. The 7 is the sum. That's where you want to get to. You want to get to that 7. In this one, the second addend is 7. I'm sorry, the first addend is 7. So you start out at 0. You always start at 0. The first addend is 7. And then how are you going to get from that 7 back to the sum, which is 5? Well, you're going to add a negative 2. So 5 minus 7 is equal to negative 2. In this case, the first addend is 5. And then you need to get to this 7. How are you going to get from this 5 to this 7? You're going to add a positive 2. You're going to move 2 units in the positive direction. So this answer is a positive 2. Again, this is hard. You have to continue to visually try to see what's going on. Eventually it becomes, you learn it. It becomes second nature, but it takes a while. This is one of the harder things, I think, in middle school math. So 5 minus 7, the corresponding addition fact is 7 plus what number equals 5? 7 plus a negative 2 equals 5. This one is 7 minus 5. The corresponding addition problem is 5 plus what number equals 7. So notice the sum in this case is 5. This number right here. The sum in this case is 7. This number right here. So the first addend, 5 plus what number equals 7. The second addend is a positive 2. So in this case right here, 7 plus what number equals this 5? Because this is the sum, the second addend is a negative 2. So the difference of the absolute values, so you take the absolute value of 7 and 5, find their difference or subtract them. 7 minus 5 is 2. But in this case, the direction is negative 2. In this case, the direction is positive 2. So in the end, subtraction is not commutative. These are not equal to each other.